Pre-statistics. Exponential functions, part 2. Lesson objective. Solve an equation of the form a times b to the n equals k for base b. Lesson objective. Illustration. To cancel a power of a variable, raise the variable to the reciprocal of the power. For example, if we have x to the fifth equals 10 and we are solving for x, I want to know what number do I raise to the fifth power to get 10. The exponent is 5, so the reciprocal of 5 is 1 over 5. So if I raise both the left-hand side and the right-hand side of the equation to the 1/5 power, I have a power raised to a power, which means I multiply. And if I multiply 5 times 1/5, I get 1. And x to the first power is x. So now all I need to do is compute what is 10 to the 1/5 power and round it off to 2 decimal places. That is 1.58. So we would say x is approximately equal to 1.58 to 2 decimal places. To check it, I take the original equation. Everywhere I see an x, I substitute 1.58. Now since this is rounded off, it's going to be close to 10, but it's not going to exactly equal 10. So if you take 1.58 and raise it to the fifth power, you get 9.85. So 9.85 is close to 10. So it checks. Let's do some more examples. Example 7. Find all the real number solutions. We have 5 problems. Some of the powers are even, some of the powers are odd. Let's begin with number 1. b squared equals 25. Now if you recall, we did problems like this back in the quadratic chapter. To get rid of the square, I do the opposite, which is to take the square root. But taking the square root is the same thing as raising it to the 1/2 power. So if you take 25 and raise it to the 1/2 power, you get the square root of 25. Now because this is even, it can be a -5 or it can be a +5. And the reason why is -5 squared is -5 times -5, which is a +25, and 5 times 5 is a +25. So whenever your power is even, you will have a solution that is both a plus and a minus. And if you recall, this is the notation. So x equals plus or minus 5. Number 2, b to the third power equals 8. What number do I cube to get 8? So if we raise both the left-hand side and the right-hand side to the 1/3 power, 8 to the 1/3 power is 2. And of course 2 cubed is equal to 8. Now -2 is not a solution because -2 times -2 times -2 gives me a -8, not a +8. So this only has one solution. Number 3, we have 2b to the fourth equals 32. To get b by itself, I need to get rid of the power of 4, and I need to get rid of 2. So for this example, I want to divide by 2 first. We get b to the fourth equals 16. Now, to get rid of the power, I raise both sides of the equal sign to the 1/4 power, and 16 to the 1/4 is 2. But because this power is even, -2 also works, because -2 to the 4th power will give me a +16. So when you have negative numbers raised to a even power, they will produce positive numbers. So our answer is b equals plus or minus 2. We could check this on the graphing calculator, or we could just substitute it in. I'm going to skip that step. Number 4, we have 10b to the fifth equals 90. Again, our first step is to get rid of the 10. Now to get rid of the power of 5, we take 9 and we raise it to the 1/5 power. And using a calculator, we say that b is approximately equal to 1.55 to 2 decimal places. Number 5, b to the 6 equals -28 has no real solution because we can't take a number raise it to an even power, and get a negative number. So an even exponent only gives a positive number. Summary: to solve an equation of the form b raised to the n power equals k for some b, number 1, if n is odd, the real number solution is k raised to the 1/nth power. Number 2, if n is even and k is greater than or equal to 0, the real number solutions are plus or minus k to the 1/n power. Number 3, if n is even and k is less than 0, that means a negative number, there is no real solution. Illustration: consider the expression 4x cubed plus 10. If x is equal to 2, evaluate this expression. Well, to evaluate, we take 2, and everywhere we see an x in the expression, we substitute a 2. Following the order of operations, we do exponents, next we multiply, and finally we add. So 2 cubed is 8, 4 times 8 is 32, and 32 plus 10 is 42. Now when we have equations in this form and we are solving for x, we follow the order of operation in reverse. Using the order of operations to evaluate, we would first cube x, then we multiply that value by 4, and lastly we'd add 10. That is the order of operations. But to solve, we follow the order of operations in reverse order, and we want to undo each operation. So the opposite of adding 10 is subtracting 10. The opposite of multiplying by 4 is to divide by 4. And lastly, the opposite of cubing x is take the cube root, or raise it to the 1/3 power. Let's actually have an equation where we do this. Consider 4x cubed plus 10 equals 10.5. To solve for x, we must undo raised to the 3rd power, multiply by 4, and addition of 10. The first thing we're going to cancel is the addition of 10, so we subtract 10 to both sides of the equal sign. We get 4x cubed equals 0.5. Next, we want to undo multiply by 4, so we divide both sides by 4. We get x cubed equals 0.125. Next, to undo raised to a power of 3, we raise both the left-hand side and the right-hand side to the 1/3 power, and using your calculator, that turns out to be 0.5, or 1/2. Let's do some more examples. Example 8. Find all real number solutions. So for number 1, we have 3b cubed plus 15 equals 96. Solution: first we want to subtract 15 to both sides. Now we want to get rid of the multiply by 3, we divide. And lastly, to get rid of the power, we raise both sides to the 1/3 power. 27 to the 1/3 power turns out to be 3. To check it, we take 3 and we substitute it back into the original equation for our variable b. Now follow the order of operations. The left-hand side should equal the right-hand side, 96. So we cube first. We have 3 times 27 plus 15. Now we multiply 81 plus 15, and that equals 96. So the left-hand side equals the right-hand side. It checks. For number 2, our first step is to undo the minus 7. So we add 7 to both sides. Next, we want to divide by negative 3. And we have b to the 4th equals negative 20. Now there's a problem. This is an even power and a negative number. So there's no real solutions. It's the empty set. If you try to take a negative 20 and raise it to the 1/4 power on your calculator, it will tell you no real solution. So we are finished. Example 9. Find all real number solutions. Round your answer to the 2nd decimal place. We'll begin with number 1. First, we want to add 3.19 to both sides. Next, we want to divide our coefficient of 5.42. So next, To cancel out the exponent, we raise both sides to the 1/6 power, and because that was an even power, we have a plus and a minus, so we have two solutions. Computing this, we have b is approximately equal to plus or minus 1.43. For number 2, we have b to the 9th divided by b to the 4th equals 70 over 3. These are like bases, so our first step is to simplify the left-hand side. So if you recall, when you are dividing like bases, you subtract the exponents. So we have b to the 5th equals 70 divided by 3. Now we want to take 70 divided by 3 and raise it to the 1/5 power. Using a calculator, we round off the answer to 1.88. To check number 1, b is approximately equal to 1.43. We plug that back into the original equation. If this is correct, the left-hand side should equal the right-hand side. So we take 1.43, raise it to the 6th power, then multiply it by 5.42, and then subtract 3.19. And we get 43.156, and that's pretty close to 43.74. Now it's not exactly because we are estimating b to be 1.43. For the negative value, we do the same thing. We raise it to the 6th power first, then we multiply, then we subtract, and we see that this checks too. So there's two solutions to number 1. For number 2, b is approximately equal to 1.88. Plugging 1.88 in for b, we have this. So this value should be close to this value. Dividing these values and dividing these values, we get 23.485 is close to 23.333. So it checks. Thanks for watching.